All right. Let's just do a couple of examples converting from polar form back into standard form. Here we go. This is example 21.8. We'll do two of these, and I think that will be sufficient to get the idea through. The key thing that we're going to need to remember are the two formulas. Well, let's see. I don't think we even need the formulas. Let's see what we can do with this thing. All right. Whoopsie. So, A. 3 times cosine 117 plus I sine 117 degrees. This is a number, a complex number in polar form. It has the modulus 3, and it has the angle or argument 117 degrees. We're working in degrees here, as indicated by the little degree symbol. Okay. Here's how we're going to write this in the standard form, a plus bi. You're going to see that it actually is quite simple. There's not a lot to remember. The things that you're going to have to do are first find the cosine and sine of 117. How do we do that? Well, if this is an angle that's a common angle and you know cosine and sine for it, fine, use them. If you don't, then let's plug this into a calculator. I'll go ahead and use my favorite calculator, Desmos, and we're going to try, let's see, cosine of, and the angle was 117. And you can see already it's giving me an answer. It's negative 0.45399, so negative 0.454. So I'm just going to recopy this and substitute that in 3 times negative 0.454. That was cosine of 117. Plus, and then I times, let's find sine of 117. So, sine of 117 is 0.891. We'll stick to 3 decimals, 0.891. Okay, so we now have that this complex number in polar form is equal to 3 times cosine of 117, that's negative 0.454, plus I times sine of 117, that's 0.891. What do we do now? We distribute the 3 and multiply it through by each of these. First we do 3 times negative 454. That's a calculator problem once again, and I will not flip over to the calculator. I'll just copy the answer out here. It is, if we do 3 times negative 0.454, we get negative 1.362. And then plus, we need to do 3 times 0.891. 3 times 0.891 is 2.673. And you'll notice that we've multiplied the 3 times that number, but we can't forget the I that's hanging around there. I. And next, we're done. That's it. This number is a complex number in standard form. It has a real part, negative 1.362, and a complex part, or rather an imaginary part, 2.673. That's it. As you can see, these conversions, provided you have a calculator or you know the sine and cosine of the angle at hand, these conversions are not too bad. Pause and do the next one. When you do the next one, try to do it without the use of a calculator and see what you can come up with. Okay. That is, I would like in the next one, part B, to get exact answers instead of decimal approximations. All right. Pause now if you wish. Otherwise, let's go ahead and continue. B. So 4 times cosine 5 pi over 4 plus I times sine 5 pi over 4. Well, 5 pi over 4, this is one of those angles that it may be familiar, it may not. It's an angle that's not in the first quadrant, but otherwise should be familiar. So let's go ahead and draw it. That always helps me. 4 pi over 4 is 180. 5 pi over 4 is going to be another pi over 4, or 45 degrees down, like this. Yeah. So this is the angle, if you like working in degrees, this is the angle that's 180 plus another 45, or 225. Same as 5 pi over 4. Now, how do we figure this thing out, the sine and the cosine? Well, we always make our triangle by dropping a vertical from our angle, the side of the angle, down to the x-axis. And you notice that this angle right here is 45 degrees, or pi over 4. And that, what we call the reference angle, if we know the cosine and the sine of the reference angle, they're going to be the same as the cosine and the sine here, with the possible exception of whether they're positive or negative because of the quadrant. Now, observation, we are here in quadrant 3, and that means that both sine and cosine are negative. So this is quadrant 3. Sine and cosine are negative, so what angle has, what is the cosine and the sine of pi over 4? Well, cosine of pi over 4, sine of pi over 4. Pi over 4 is that one 45-degree angle in which the cosine and the sine are the same. They're equal to each other. They're both of the form radical 2 over 2. And since we're in quadrant 3, for us, we have the cosine of 5 pi over 4 is just negative radical 2 over 2. And similarly, the sine of 5 pi over 4 is negative radical 2 over 2. And all we're going to do is just substitute in these values into this expression and then simplify. Let's see how it looks. So next step, we keep that 4 in the front. Cosine of 5 pi over 4 is negative radical 2 over 2, plus I times sine of 5 pi over 4 is negative radical 2 over 2. Now what do? We're going to take the 4 and multiply it by each piece. So this is equal to, when I multiply 4 times negative radical 2 over 2, the 4 and that 2 on the bottom cancel. The 2 cancels with the 4 and leaves a 2 in the front. Multiplying that by that negative radical 2 on top, altogether I get negative 2 radical 2. Similarly, 4 cancels with the 2 in the second term, and we get, let me see, it's going to come out to be negative 2 radical 2 times I. So here we go. This is in standard form. That's our complex number in standard form. Negative 2 radical 2 minus 2 radical 2i. The real part is negative 2 radical 2, and the imaginary part is also negative 2 radical 2. That's it.